Hello. Today we're going to talk about similar triangles. Now we're going to talk about three similar triangles, three different ways to determine if triangles are similar. These are shortcuts so that we don't have to prove that everything is similar. We just have to prove 2 or 3 things rather than all 6 parts like we did in the last video. The first method that we're going to do is called angle-angle similarity, which is AA. And if I can prove that 2 angles of this triangle are congruent with 2 angles of that triangle, then I can prove that these 2 things are congruent. So that means that this angle is congruent to that angle, and this angle is congruent to this angle, then I have congruent triangles. Using AA congruency. The next one that we're going to talk about is side-side-side similarity. Okay? So here we're looking at all 3 sides of a triangle, and they all need to be proportional to each other. That means they all need to come out to the same simplified fraction. So, for instance, if I have this triangle, and this triangle has sides of 3, 4, and 5, and this triangle, they're all doubled, so let's say that that would be 6, this would be 8, and this would be 10. Well, that's going to create a ratio over here. So 3 over 6 is the same thing as 4 over 8, which is the same thing as 5 over 10, because all of these equal 1/2. And so these would then be similar based on side-side-side similarity, because all 3 sides are proportional. And the last shortcut to proving triangles similar is side-angle-side similarity. So basically, if we can prove that 2 of the sides are proportional, and the third side, and in between those 2 sides we have a congruent angle, then I know that these 2 triangles are in fact congruent. So that means if I have this triangle marked like this, and use those 2 same sides as I did earlier, but now I can also prove that this angle right here is the same. Well, 3 over 6 equals 4 over 8. These are both 1/2, and I have a congruent angle. So that would be side-angle-side similarity. Now, let's go ahead and put this into practice a little bit. So, I have basically one small triangle nested in a larger triangle, and I want to know if these things are similar. Well, the first thing I notice is that both these triangles share angle J. I'll go ahead and write that note. They share angle J. So that's my congruent angle, so I either need to find another congruent angle, or I need to find proportional sides. Well, this is a length of 2, and this side would be side length of 6. 2 plus 4 is 6. Well, that equals 1/3. This side is 3, and this whole side, 3 plus 6 gives me 9. So 3 over 9, well, that also equals 1/3. So are they similar? Yes, they are similar. Why? Well, we used side, angle, side similarity. Our statement, well, let's go ahead and just say JKL. So triangle JKL would be similar to triangle. Well, if I did J, then K, then L, then I need to do J, then M, then N. J, M, N. And our ratio, well, that would be our ratio that we wrote down right here. So 1:3. Let's go ahead and tackle the next one. I don't know any angles I don't share any angles, but I do know all three sides. So 4, 4, and 6. So 4, 4, and 6. And over here we have 6, 6, and 9. And the question is, are these equal? Well, 4 over 6, of course, equals 4 over 6, and those both equal 2/3. And 6 over 9 also equals 2/3. So yes, these are similar. Why? Well, this is because of side, side, side similarity. And our statement, well, let's go ahead and just say PQR. And if I do PQR, where Q, that's the one in the middle, well, that means R needs to be in the middle over here. And let's just say PRS. Because since it's isosceles, it doesn't really matter if I start with the S or the P so long as the R is in the middle. Similarly, ratio. Again, that would be the ratio that we used over here. But instead of as a fraction, we're going to write it as a ratio with a colon. Let's jump down to the bottom two examples. Over here, I know these two angles and I know those two angles, and I'm wondering if they're similar. And at a glance, it seems as though they're not. They both have 52, but this is 81 and that has 47. But I don't know what this angle is. It could very well be 47, and that one could very well be 81, and so let's figure this out. Well, if I do 81 plus 52, well, that's going to give me 133. And so 180 minus 133, that's going to give me 47. So that means that this angle is 47, and if you'll now notice, the 52 and the 47 are in fact shared, and so yes, they're similar, and they're similar because of angle-angle similarity. My similarity statement, well, if I say A, B, C, well, then I need to go F, G, H. But as far as my similarity ratio, we don't know the similarity ratio because we did not have a proportion to work with. So I'm just going to write unknown there. And now we move on to our last example. And if we look at this, well, I see a shared angle here, and I see that this is a right angle. Because it's a right angle, that tells me that this must also be a right angle. And now I have angle-angle similarity. So these are also similar triangles. Our similarity statement, let's go with the one I have marked to the right to the unmarked, so angle TSQ. So triangle TSQ and PSR. And again, because we did not have any sides to compare, our similarity ratio is unknown. So this was 3 shortcuts to finding similar triangles.